here. Parallel lines are two lines that are parallel if and only if they have the same slope and different y-intercepts. If they have the same y-intercept, then those two lines are literally the exact same line. So typically they are going to have different y-intercepts, but the most important thing is the same slope. Okay? For perpendicular lines, two lines are perpendicular if their slopes have opposite signs and are reciprocals of one another. So let's talk about reciprocals and refresh our memory on that. If I have a fraction 1/2, the reciprocal is the fraction turned upside down. So this reciprocal is 2/1, which is simplified to be the same thing as 2. So this is not equal to each other actually. So this is the reciprocal. Okay. If I have, let's say, -3, the reciprocal, this is over 1. So take a whole number, put it over 1. And when you flip it, you get 1/3, but the sign stays with it. So reciprocal does not change the sign, it just flips it. However, in order for two lines to be perpendicular, they must have opposite signs and be flipped from one another. A quick check of that is if you have two slopes and you can compare the slopes, then if you multiply those two slopes together, you will get the resulting amount of -1. In order to do that for our A part here, we are going to put this in slope-intercept form. Another way to think of this is to solve for y. So we're given two lines. We're not quite sure what their slopes are in this format. We want to put it in slope-intercept form. So we're going to go through the process of solving for y for both of these. The first one here, solving for y, requires us to subtract 8x from both sides. And again, I'm trying to put this in the the slope-intercept form. So the y equals mx plus b. So on this side, I have 7y. But I want to put this x term first. Lastly, we're going to divide by 7 for each term. So I have y equals -8/7 x minus 1. So what is my slope in this problem? My slope here is the number in front of our x value. That's your m. So we have -8/7. All right, let's do the same thing over here for this one. I'm going to move it over. 7x minus 8y equals 16. And again, I'm solving for x. So we're going to move this 7x over by subtracting. I get -8y equals, again, putting this in order. So my -7x goes first, then the plus 16. And the trick here is if we divide by -8, we're dividing each term by -8. Do not change the sign here. Keep the negative with it. So this will be divided by -8. That will make that cancel. But if I divide that by -8, I must divide this by -8 and this. So I have y equals, let's simplify this. Two negatives make the positive. 7/8 x. Here I have minus what? 2. Okay, so we did all of that work, but we still haven't determined whether these pairs of lines are parallel, perpendicular, or neither. So what I would suggest doing is taking this one, and we're going to use this one. So our slope on that first one is -8/7. If we do the opposite sign, what do you get? So you get, take off the sign. So two negatives make a positive. I'm doing the opposite of this sign. So if this is negative, this one is going to be positive. And then we're going to do the reciprocal. So I flip it over. And now if these are perpendicular, this and this will be the same. Let's talk quickly about what would happen if these are parallel. So my first check should have been, does this slope, 7/8, equal -8/7? Well, we could see very quickly that those are not the same. So these are not parallel. They're not parallel lines. Okay? Our next step was to check the slope, change the sign, flip it over, see if that equals our second line. And indeed it did. So we can say here that these lines are perpendicular. Okay? If, for example, in the process of flipping it and changing the sign here, this sign was different than this sign, but the numbers were the same. So for example, this was 7/8, but this was -7/8. That would be neither. So it's not parallel, nor is it perpendicular. So if I had the exact same numbers, but the signs were different, that would be neither. Okay?